Hello everyone, welcome to ServiceRegistry Talk, where I will explain how we at Tier bootstrap infrastructure for new services and manage access to it by just one Git repository. Tier is a micromobility company that is operating in more than 17 countries, originally from Berlin. We are more than 1,000 employees worldwide. We are managing more than 280 Kubernetes nodes. We are storing more than 130 terabytes of data in AWS S3. And who I am, my name is Timur. I'm working as a senior DevOps engineer in a core infrastructure team. I've joined Tier earlier this year. And you can find me on GitHub and LinkedIn, and send me a friend request or message or question. I will be glad to find out more about your challenges as well. And let's talk about Tier infrastructure landscape. As you can see on the diagram, we have quite plenty of different services and platforms involved in our infrastructure landscape. We store all source code in GitHub. We use CircleCI as our CI/CD tool for building and deploying our services via Kubernetes, Helm, and also as I said, we're building the images and pushing them into AWS ECR. We also use Spacelift, which is a CI/CD platform for deploying infrastructure code. It currently supports Terraform and Pulumi. We use OKTA as our central authentication tool that is managing access to AWS, to Vault, to Kubernetes, to Slack and PagerDuty and Datadog and everything. Literally everything is authenticated and authorized via OKTA. As I said, all our services are running in Kubernetes. We store all of our service secrets in Vault. We use Datadog, Sentry, Jagger to trace and log the services. We use Grafana to get insights of the information, the metrics accumulated by Prometheus, and then we use all that information from Datadog, from Prometheus via Alert Manager to actually forward the alert to responsible people via Slack and PagerDuty. Now let's talk about how everything has started. So in the early ages of Tier, we strongly believed that teams are immutable, teams are going to stay, and services might come and go, but teams are going to stay like they are for a very long time. So we built our infrastructure around teams. We had a service repository and we had like a team infrastructure repository, which had the infrastructure related to many services managed and developed and operated by a certain team. Unfortunately, this was proven wrong in just like 2 months, and we started thinking how to solve this problem, and we decided that we should go into from the team-centric approach to a service-centric approach, which means that the service is self-contained. The service repository has everything it needs to run. It has documentation, it has infrastructure code, it has Kubernetes manifests, it has the CircleCI pipelines definition, it has unit tests, it has Docker files, it has everything to run without ever knowing who is responsible for itself, for the service. So if you need to do anything regarding the service, you can just do that there. You don't have to look up which team owns it. You don't have to go into repository where the infrastructure for this service is stored. So all information that you need is in the service repository itself. How does it look like? Here on the diagram, you can see that we basically want to achieve that a team can own a service, and also a service can be, let's say, accessed or owned by multiple teams. Like, for example, service A is owned by team A, and it's also accessed by team D, as well as service B is accessed by team E and owned by team A. We want also to achieve a situation when, for example, a team B that you see on the screen splits into team D and E, it's easier to change to do the split without actually touching the service infrastructure. And also what we want to achieve is that it should be easy to change ownership. For example, that service C is owned by team A, but we say that now the ownership should be completely moved to a team E. Again, we want to do that flawlessly, and we want to do that effortlessly. And here, the key role in this plays the service registry. The service registry is a central place where we register a service in Spacelift. So we create a Terraform pipeline for its infrastructure pointing to the service repository. And service registry is the place where we create teams, is the place where teams claim access to services, is the place where teams held accountable for their services their own. How do we do that? So if you would have a simplistic view over the service registry repository, you would probably have a folder with services or with service configs. We decided to go with YAML as a more human-friendly and maybe easier to operate format, where we basically have we have every service developed a tier defined in a separate YAML file. We have a prefix service and then the service name. And on the right side, you see the example of a service config YAML, where you have attributes that are meaningful for your organization, for your developers, for your operators. For us, it might be, for example, having a service name, having a repository URL, having the namespace of the Kubernetes, for example, in cases where you want to have multiple services running in the same namespace. Maybe it makes sense from logical perspective or from a business perspective. Also, you might want to have information about which cluster the service is going to be deployed in, and maybe then the branch, the main branch that is going to be watched by your CI/CD, but in our case is Spacelift. So Spacelift is going to watch in this repository, in this branch, and it's going to use this Terraform version to actually deploy this infrastructure defined in the service repository. Then we have teams also defined in service registry. Again, it's YAML files, a prefix with team, and then the team name. And then you have information that is relevant for your organization. For example, the name of the team, the department, if the team is on call or not, if it's responsible, and if it's responsible, then how to reach out the team via Slack, for example. And then, for example, we use owners and guests, where owner is a team that has read-write access, or basically operator access to the service, and guest is more like a read-only collaborator level access. Then I would like you to have a look at our implementation from roughly 10,000 feet. So I will just explain it in very in just a couple of words. We use quite a lot of built-in Terraform functions to scrape the data from the YAMLs and transform it to actually feed it further to the Terraform modules we developed that are then deploying the infrastructure we need. For example, from the services perspective, we are scripting everything with a for loop and the YAML decode functions to create a map. Then we create another map where the key is the repository name, because we want to use this information, this map, to further create a Spacelift pipeline per repository. We don't want to have multiple pipelines pointing to the same repository. We want to have only one pipeline or Spacelift stack, how they call it, is a project. We want to have one stack per repository. That's why we are creating another map with the basically deduplicated information based on only on what we need. We also export the first map with all services simply scraped via Terraform output, so that we could then feed them into Teams module, so that the teams could take the information from the service configs to create the access. This will be explained later. And eventually we create the Spacelift stacks via Spacelift Terraform provider based again on the information from the second map. So if we have a look at the Teams implementation, it's pretty much similar. We have the for loops, we have YAML decode function, we import the services map that we exported in the services module, and then we are mapping services to the teams, or we're basically mapping information from services to the teams, or only for the services that are owned or accessed as a guest by a team. And then we start creating the teams, creating access for them to the service. We have multiple Kubernetes clusters, and I think we have 5 at the moment. And certain services live in certain clusters, and we only want to give a team access to a service, to a cluster, to service in a cluster that it owns. So basically, you do not get an access to the namespace called my service 1 in all clusters, only in the cluster that has this service. Now let's have a look at the overview of providers we use in ServiceRegistry directly and indirectly. As you can see, it's quite some, 6, 7, 8 providers. Let's start with Spacelift. As I said, Spacelift is a CI/CD platform for infrastructure as code. It supports Terraform and Pulumi, and based with the Spacelift provider, we create the pipelines or the Spacelift stacks that are pointing to service repositories. And in the service repositories, we, as I already mentioned, we have the Terraform infrastructure code. So basically, it will pull them. The stack will be watching the changes in this folder and automatically be triggered and deploying as normal CI/CD stuff. But in the service registry itself, it's only the Spacelift stack that is created from the service perspective. So the service registry does not know anything about the infrastructure itself that will be deployed, only the stack. And there are also a couple of additional resources like environments, variables, context, configs, and so on and so on and so on. Those are all specific to Spacelift provider resources. Next, we have Pagerduty provider. This one we have from service perspective, we create the services in Pagerduty is a resource called service in Pagerduty. We also have enabling Slack integration. We also integrating a Datadog, and then eventually we also have resources in Pagerduty provider that are related to teams, such as we create a team and we have a schedule and escalation policies for a team also created automatically in this module via this provider. And from this point, all other providers are only gonna have teams perspective. So basically, we do not do anything else with other providers service related directly. Everything about AWS, Kubernetes, Vault, service from the service perspective is running inside of Spacelift pipeline that we created in the previous slide. Let's have a look at Datadog. We use, as I said, we use it for monitoring, we use it for logging, we use it for tracing, and we have alerts based on it. And we want these alerts to land in Pagerduty to eventually notify the teams that own the service, or the team that owns the service, that something is wrong, something's happening there. Probably I forgot to mention, we have a vision that there is only one owner of a service, so that we don't want to have clashes of who owns which part of a service. So we say one service is owned by only one team, but there might be like collaborators, we call them guests, but ownership and on-call and all that stuff is only handled by the team that owns the service. Let's go to the next slide, which is the OKTA provider. As I said, we manage all the access to everything we have via OKTA, and specifically from team's perspective of ServiceRegistry, we create OKTA groups. We call them operators and spectators. Basically, operator is a read-write collaborator, and spectator is only read-only collaborator. We also have an admin group created in OKTA per team, which is able to assign operators and spectators of a team, like users, to those groups. So we have 3 groups created per each team. And so that we as a core infrastructure do not want to manage the members of operators and spectators that change quite often. People come and go, they're promoted and stuff like that. So we just assigned for example, team leader as an admin into the admin group, and then he will be able, or she is going to be able to manage the rest of the team. Next is AWS. AWS is our main cloud provider where we run our workloads. From team's perspective, we create IAM roles per team, again, operator and spectator, and then based on information that we have in team config of which service we own, we allow operators to interact with those resources via CLI, via API, via Consul. You can create, delete, and do stuff like that based on tags. So basically, in the permissions, we say, in the permissions of the operator's role, we say this operator is allowed to perform these actions on all resources that have a tag service and then the name of the service that the team actually owns. So we manage the access based on tags that every resource that is created has, like service name and then the name of the service. While the spectators can have read-only access to all resources in our AWS account. Next provider is Vault. Vault is the central place where we store all our secrets. There we create spectators and operators. We create vault policies to allow the operators to read and update and delete secrets related to a certain service, while spectator can only list services or list secrets of a service, but not read or modify it. And last but not least, no, it's not last. Okay, we have Kubernetes and Helm provider. We merged this into one slide because they basically achieve the same thing. They deploy Kubernetes resources in your cluster. We use Helm to we have a custom Helm chart that is deploying our custom resource called AWS Auth Mapping, that is allowing us to map multiple IAM roles to Kubernetes roles to provide access to people, for humans, to Kubernetes resources related to a certain service. You can have, we actually already talked about it in our blog. So if you click on the link down below, you will be able to read more about our AWS auth mappings and our auth operator that is handling all of these custom resources to actually perform the job we need. And besides that, we also have Kubernetes provider that is binding those roles. We create a role per team, again, operator and spectator, and we create a binding based on the namespaces. So basically, we read if a team owns a service, it is an operator. So and this is operator, then we read the namespace in which service is deployed that we have in the service config that we, as you remember, exported from services, imported into teams, and now in teams we take this information and create a certain we could create a role binding to this namespace. And now, last but not least, is the Slack provider where we only create channels for departments and teams, or basically for teams where we include information. In this channel, we communicate. Not we communicate, but the alerts are landing so that people from the team could quickly get more information and get notified if something happens with the service. As I said, we have Datadog alerts, and we have Alert Manager that is taking information from Prometheus to alert. Now let's have a short summary. Service is self-contained. Service has no idea of who owns it. Service has all information it needs to run. It has infrastructure, it has Kubernetes code, it has source code, it has pipelines, definitions, documentation, Docker files, everything. And we use ServiceRegistry to register those infrastructure pipelines and to register teams and to register access of those teams to services they own or where they are guests or collaborators. And that's it for today. Thank you for your attention. Have a look at our tier engineering blog. Have a look at our open positions. And if you have any questions, this is the time to ask them. I'll be glad to answer them when I can, or I will communicate you later if I cannot answer them right away. Thanks for listening.